Hello, everybody. I'm super excited to get to be back in Korea. We got to do a strategy day very similar to this, maybe not quite as big, last year, right around April, May. So it's always fun to be back in Seoul. I think we started the tradition last year, so I want to keep it up and get a selfie with everybody in the room here. So if everyone can join me and get ready. So this is going to go on my LinkedIn. Say cheese. There we go. Awesome. Thank you, everybody. Thanks, everybody, for being here. As JD sort of kicked off, I'm going to spend today talking a little bit about kind of the HashiCorp vision, the strategy, and where we're investing to really help make it easier to do cloud. And as we talk about doing cloud right, what does that mean? How do we think about it? And what have we learned really working with thousands of enterprises around the world as they're going to cloud? So, just to kind of kick us off here, I think many of you are probably familiar with HashiCorp. But to give a kind of a quick snapshot of HashiCorp by the numbers, today we do about 500 million downloads of our open source software every year. So that almost means that every country, almost every account that I go to, there's people using the HashiCorp tools, whether that's Terraform, Vault, Packer, Consul, Nomad, and the others. Today we have about 4,400 customers around the world. Many of these are some of the biggest companies in the world. So we count about 500 of the 2,000 biggest companies as customers today. And many of these will be recognizable in Korea as well. Customers like Samsung, LG, Grab, and many, many others. So super excited to be here. We find it to be an honor and a privilege to get to work with all of these organizations. We take our role very seriously as a technology partner, helping enable you all on your journey to cloud. I think what's fun for us is having played this role over the last, call it 12 years of HashiCorp, we've gotten to see how cloud has evolved. And one of the things we do is every year, we run this survey that we call the State of Cloud. And so we ask thousands of organizations to tell us more about their journey to cloud, where they're struggling with, where they're maturing, what tools they're using. And so it gives us a very unique insight into how the overall market is in their journey to cloud. One of the things that I find very interesting is obviously today, a huge portion of organizations are sort of using cloud, right? Almost 80% say they're adopting cloud in one shape or another. And this has changed a lot versus when we started doing the survey a few years ago. So almost every organization is really now embracing cloud. But then when you look at how many organizations would say they're mature in cloud, when we look at a number of different metrics and measure maturity, it's a very small number. Only about 10% of organizations would say they're doing cloud effectively. And so I think that's super interesting, and it really speaks to some of the challenge that we'll talk more about. At the same time, when we sort of start to look at that and say, okay, well, even though you're still early on your journey, are you seeing value out of cloud? And most organizations say yes. Almost 90% are seeing some benefit, whether that's helping them save cost, whether that's helping them deliver applications faster, whether it's reducing the amount of manual work they have. So clearly the value is there. The hard part is being mature enough to really do it at scale, right? And that's when you see that 8% number in terms of these highly mature organizations. So when we sort of look at this over and over, you kind of start to see some of the challenges when you're not at maturity, right? One of the top issues we see over and over is cloud spend, right? And almost 91% of customers report to having overspent in cloud, and we see this all the time, right? Infrastructure that's left running too long, developer environments that nobody ever shuts down, production environments that are oversized. So lots of different ways that you can misconfigure and overspend in cloud, and we see those pretty regularly, right? At the same time, when we look at the large, high-profile security issues, almost 90% of them start with a stolen credential, right? It's either a default username and password that wasn't changed, or it was an insecure storage of a credential because someone left it in GitHub, or they hard-coded it in a script, and an attacker finds that credential and uses it to move throughout the network, right? And then lastly, when we look at what's the overhead of developers of managing and delivering applications in the cloud versus spending time actually writing code, working on the application, what we find is an incredible amount of time goes into things like doing upgrades, patching, making sure the application's reliable, learning cloud tooling, versus focusing on the business logic of the application, right? So there's obviously a lot of developer productivity that we're missing out on because of this complexity. So lots of interesting learnings, and these all feed into how we think about our roadmap and how we sort of can better help customers. At the same time, we have a relatively large announcement. I know JD talked about this a little bit, but IBM has announced their intent to acquire HashiCorp back in April. So we're going through the standard review processes, as HashiCorp is a public company, and so there's a certain level of scrutiny and review that we have to go through, but we expect that this will be complete sometime this year. I think a common question we get from the community is, what does this mean, right? We're using these tools, we're using HashiCorp technology to build our cloud. Does this change anything about how we build or use HashiCorp? And the short answer really is no, right? The key value for us in partnering with IBM is really two things, right? One is today we operate in about 30 countries around the world. IBM operates in 175, right? So a much, much bigger reach around the world when we think about relationships with customers, relationships with partners, ability to operate in different countries. And so our goal is to help bring HashiCorp to a much bigger, more global audience, right? And especially even in countries like South Korea, we have a limited presence here, but IBM brings a lot more resources to let us support a bigger customer base here, right? So super excited about our ability to support more customers in the HashiCorp ecosystem. At the same time, on the research and development side, IBM sees the value of the whole portfolio HashiCorp has in enabling a hybrid multi-cloud strategy, right? So starting with their Red Hat acquisition back in 2019, IBM's been very focused on enabling customers no matter which cloud provider they're in, whether that's on-premise, Amazon, Azure, Google, et cetera. So HashiCorp portfolio really fits into that mission of enabling a hybrid cloud. So what you'll expect to see is more investment in really driving that story around how do we do hybrid cloud automation, bringing tools like Terraform and Ansible to make them work better together, bringing Kubernetes and OpenShift closer with tools like Vault to really enable a seamless experience across a multi-cloud management portfolio. And then I think JD talked about this as well. HashiCorp will retain as an independent division within IBM. So we'll continue building software as HashiCorp under the HashiCorp brand. If you're coming to events like these strategy days or our big user conferences like HashiConf, expect those to continue as we go into the future. So as we talked about, we get to work with these thousands and thousands of companies around the world going to cloud. And in many ways, we've gotten to see cloud done well, cloud done okay, and cloud done badly. And there's a few themes that are very common when we see what does cloud done well look like, right? When we look at the best companies really doing cloud in a mature way, there's a very common theme that comes out of it. The first is really thinking about what does that application delivery chain look like? What are the key processes or life cycles that are end-to-end in delivering an application? And what we find is there's really four critical ones that are important for every organization to define and standardize around. The first is the most simple, it's the most straightforward, it's application lifecycle management. For most organizations, this is adopting something like GitHub or GitLab or Azure DevOps to really create a consistent way of how you manage source code, how you do CI/CD, testing, building, the lifecycle of really managing an application before it gets to production, right? As we get into production, then the next two major steps become infrastructure lifecycle. How do we stand up and manage the underlying infrastructure that our applications are run on? How do we deploy the applications onto that infrastructure? And how do we keep that infrastructure and application up to date as we're patching it, scaling it, making sure it's secure and compliant? Then when we think about security lifecycle management, we have the same challenge when we think about credentials. I might create a database, but where does that secret go, the username and password for my database? How do I save that in a secure location? How do I rotate it every 90 days to make sure I'm staying compliant? How do I report on that for my compliance team? So there's a whole life cycle of how to manage secrets and keys and certificates in an effective way. And then lastly is the monitoring life cycle, right? This might be tools like Splunk or Datadog. but I need a standard way to have visibility across all of my applications. Otherwise, you start to run tens or hundreds or thousands of applications in cloud, and you have no consistent way of knowing, are they up and running? Is there a bug? Is something down? Is there a cross-service issue? How do I debug these things when I have a complex cloud environment? So having a consistent way to monitor all of these becomes super critical at scale. So these four become really critical. The middle two is where HashiCorp focuses on, and then we partner closely with many technology companies, both on application lifecycle and in monitoring. The next piece is more of an organizational question. How do we design an organization to effectively enable many different application teams to be successful as they go to cloud? And so often what we see is most organizations start by letting every application team build and deploy to cloud in their own way. So that's okay when you have 5 application teams or maybe 10 application teams. But as you start to get to scale and you have dozens or hundreds of different application teams, each doing cloud in their own way, it creates a huge issue. It becomes very hard to do standard things like doing version upgrades, doing patch management, doing security, doing compliance, managing your cost in cloud, because every one of these teams is doing it in a different way. So when we look at the really mature organizations, one of the keys to their success is creating a central platform team. The role of this central platform team is really to be the expert in how the cloud services should be used and to build a common set of standards that the applications can use. So rather than every team running their own GitHub, running their own provisioning tool, managing secrets in a different way, the platform team establishes a common standard, they run it as a service, and then the application teams get to consume it, right? So this is both a tooling and a technology question of how do I standardize on different technologies, but it's also an organizational design of how do I create a set of experts that deliver a platform for my many tens or hundreds or thousands of application teams. So part of our focus at HashiCorp has been how do we make this easier for our users and our customers? And this is really where we've brought the notion of the infrastructure cloud to market. What we're really focusing on is within those 2 pillars around infrastructure lifecycle and security lifecycle, creating an integrated set of experiences across our product portfolio. So when we think about tools like Terraform and Packer and Waypoint and Nomad, they're all focused on that lifecycle of building, delivering, and managing applications. So how do we bring them together, deliver them as a cloud service, and integrate the workflows to simplify all of those different pieces of management? Same thing on the security side. When we think about it from a security perspective, we have tools like Vault and Boundary and Consul and Radar, each solving a different set of problems, but all together focused on that life cycle of managing secrets and keys and certificates. So how do we bring those together as an integrated offering around security lifecycle? So our core is to enable these platform teams to run these technologies, configure them for their application teams, and let the application teams focus on building applications rather than managing infrastructure. Ultimately, we think about with each of these things, there's really a maturity curve every customer is going on, right? So it might start with customers that maybe are new to infrastructure as code, where they're still managing infrastructure by logging into the Amazon console and pointing and clicking to manage infrastructure. That's okay, a lot of people start there. And that's a good way to experiment and learn in the cloud, but it's a bad way to operate when you have thousands of applications. Because it doesn't scale, you're gonna introduce inconsistencies in infrastructure, it's hard to secure, it's very easy to have human error in those environments. So you start at the very beginning of this sort of maturity curve by moving to infrastructure as code, adopting codified practices, putting automation in terms of how you're making changes in production environments. And then from there, you can steadily move up to higher levels of sophistication. This includes collaborating on infrastructure with teams. It includes getting to standard modules and blueprints so that you're not reinventing the same patterns over and over. It's enforcing policy in an automated way with policy as code. And as you get to the highest levels of maturity, it's enabling true self-service for developers, where they can consume and deploy their applications without needing to be experts in the underlying infrastructure. Same thing when we think about security. For many organizations, they start with no practice around secret management. So keys, secrets, certificates are all over the environment with no central approach. So the start point becomes having a central way of at least managing those secrets and storing them and enforcing policy around them. And then increasingly moving to places where you have auto-rotation of these certificates, being able to move to short-lived dynamic credentials, and really getting to zero-trust models where not only are we protecting the secrets, but ultimately we're encrypting the customer data as well, right? So moving from basic key management all the way up to high levels of data encryption and data protection, right? So it's a journey that for many customers is multi-year, and our goal is to provide a blueprint for users to say, okay, where are you on this journey? And then we can help you go from one level of maturity to the next. The mission of all of that is really for us to be able to help customers do cloud right. Having seen thousands of organizations do cloud not right, we've seen how that can happen. And so we want to be prescriptive to users of this is how we think you should do it, both in terms of designing platform teams, standardizing on tools, and going through a maturity curve of getting to higher levels of automation and sophistication in cloud, right? So now I want to switch from the slides to my whiteboard, where we can go into a little bit more of sort of the details of our roadmap and where we're investing across the HashiCorp portfolio. So I'll start at a high level, and then we'll drill deeper into sort of the various aspects of the portfolio and how they tie into infrastructure lifecycle management and security lifecycle management. At the very top, I think what's always been true for us, it's about how do we support development teams as they're delivering business applications. Ultimately, that's the value for any organization. The infrastructure that it runs on is sort of a necessary evil. It's plumbing, but it's not the value. The applications are the value. So the challenge is that infrastructure that's delivered by mostly operations and security teams is now increasingly fragmented. So for many customers, they might be on Amazon, Azure, GCP. They might have, private data centers and other cloud hosting solutions, right? So when we look at that, this is making it increasingly hard for our application teams because they have to now handle so many different environments that they might be running in. Same for our operations and security teams. They have to think about so many different ways of solving the same problem in each environment. So we think about HashiCorp as sitting in this middle box. And we solve a few different problems. The first is for our application teams. How do we enable a consistent way for them to deliver across all the environments they're running in? So a great example of this is something like Terraform. I can have a single pipeline for Terraform, build a CI/CD solution around it, and then it doesn't matter if I'm delivering an app to Amazon, Azure, or Google. I can have one tool and one workflow for how I'm delivering that, right? On the other side over here, it's what's the relationship between development teams and operations teams? And classically, this was always a ticket-driven approach. If a developer wanted infrastructure, they filed a ticket, and they waited for an operations team to set something up for them in the cloud. If a developer wants a certificate, they file a ticket against the security team and wait for someone to manually generate a certificate for their application. So how do we move away from that and really get to an API-driven model so the developers don't need to file a ticket and wait? They can hit an API and dynamically get infrastructure or certificates or secrets or whatever they need. And now this can be a part of their CI/CD process. It could be part of a UI. But developers are no longer stuck waiting on someone else. The goal is really to get to a true self-service experience. Now, at the same time, we know in many situations, developers aren't aware of all the cost implications, security implications, compliance implications. So we don't want it to be the Wild West where developers can do anything they want. Instead, we need to have some ability to have governance and control for the central operations and security teams So they can define a sandbox to say, as long as you're within my sandbox, you can make whatever changes you want, but you can't break my security or compliance or cost, right? So this becomes that difficult balancing act between how do you provide control to the central teams while giving self-service to the application teams while making it consistent and portable across a multi-cloud estate. That's ultimately the HashiCorp focus. And you can think about it as, again, we split into those two layers, infrastructure and security. And with each of these, there's a life cycle that we think about. So when we start with infrastructure, the way I like to think about it is through a timeline of what we have to do when we're managing. So if I think about day 0, when I start with cloud infrastructure, the first things I might need to do is build a machine image or container. Then I might need to provision my underlying accounts and networks and VPCs. So this is the underlying foundation to deploy my applications into. But then I get into day 1 where, okay, I have the foundation, now I want to deploy the app. So how do I have a library of reusable patterns? If I'm deploying 1, 5, 10, 50 Java applications, I don't want every one of them to look unique. I want a library of common patterns that I can repeat so that every app team isn't rebuilding the same thing. Then I want to be able to apply and enforce policy against it. So if my 51 application goes to cloud, I know it's secure, it's compliant, it's using a standard practice. Then as I get into day 2 of operations, now I might have to worry about a different set of concerns. I have a security issue, so I have to go patch all 50 Java applications. There's a new version of Java that comes out, fixes an issue. How do I go update all of my applications? At the same time, I might have users that are logging into Amazon and changing things in the console. They might change tags or security groups or other settings that might create a security risk for me or an operational risk for me or a compliance risk. So there's drift in my environment that I need to detect and then go manage. And then as you get all the way out to day N, you think about things like cost optimization and management. I have hundreds of apps running in cloud, but where am I spending money? This app might be $10,000 a month. The next app might be $100,000 a month. This app might be $1 million a month. How do I know where that's being spent so I can charge it back appropriately, focus on optimization, force some application teams to stop deploying? So how do I have visibility into my spend, but then how do I optimize it as well, right? So you start to think about this entire life cycle, right? And then thinking about constantly reporting out on things like compliance goals, right? I have to recertify to my auditors all the time that I'm following PCI or ISO or SOC or any of these different compliance standards. So when we think about infrastructure like this, there's this sort of life cycle of concerns. And what often happens is the development teams only care about this part. Because for the developer team, you want to build your application and put it in cloud and deliver your feature. So you're just concerned about how quickly can I get to day 1 and put my app in the cloud. The challenge for most organizations, though, is that this part is actually 80% of the work. Because once I've deployed 100 apps, 1,000 apps in cloud, I'm always patching something. Something's always out of date. Something always has a cost issue. Something has a security issue. And so now you have to maintain all of that forever, right? So for most organizations, 80% of the time is spent in day 2 and beyond. But most of the attention goes to designing our platforms for day 0 and day 1. So for us, we're really looking at it through this lens of saying, how do you make an organization more efficient? It's through automation of the day 2, day 3, day 4 activities, because that's where I'm going to get the most return on being able to reduce that 80% of work to 50% to free up time to build new applications, to optimize my infrastructure, to do new things, right? Otherwise, we're spending all of our time just maintaining the existing infrastructure and never really pushing it forward. So oftentimes, people will start over here with the open source tools, right? You might use Packer to do the image and container builds. You might use Terraform to do the provisioning. Oops. But as we get into sort of day 1 and beyond, this tends to be where we're focused on with things like HCP, the HashiCorp Cloud Platform, which is really focused on then solving these day 1, day 2, day 3 operational challenges at scale. Now, at the same time, going back to sort of this view here, one of the biggest challenges is the development teams mostly don't care about infrastructure. They don't want to learn Terraform. They don't want to learn Kubernetes. They don't want to be experts in configuring and setting up VPCs and security groups and networking. They want to focus on their application. So through this whole life cycle, a different part of our focus is really how do we abstract the infrastructure and make it invisible to the developers. So if I think about most development teams, what we want them to focus on is really two things. What's the source code of their application? And what's metadata about the app? So they might say it's a Java application, it needs a Mongo database, it needs a Redis cache. That's what they care about. They should be able to then feed that in to a layer like Waypoint, where underneath how this works, they don't care about, right? Instead, it's our operations teams who are going to define these blueprints to say, how does a Java app work? How does a Mongo database get provisioned? How about Redis, right? And so the goal of a solution like Waypoint is to allow the developer to focus on a set of golden patterns and then allow the operations teams to define how they work with something like Terraform. So then Waypoint basically can create a Terraform workspace and automatically provision the infrastructure using existing blueprints without the developer needing to learn or use Terraform directly. They might have some input to say, I want a small Mongo or a medium Redis, and those will be inputs to the execution, but they don't need to know how it works. So this starts to solve the day 0 and day 1 problem, because I can define a set of golden patterns for my developers to use without having to know how it works. But then when you get to day 2, day 3, day 4, there's still a challenge of a set of workflows that the user has, right? So a set of golden workflows they need to be able to execute. So if you think about a Java application, they might want to build a new version. Then they might want to deploy that new version. If something goes wrong, they maybe want to do a rollback, right? Maybe something is stuck, and so they need to restart the application. These are actions that the users might want to do in day 2, day 3, day 4 when they're operating these applications. But if they have to be an expert in how the infrastructure works, now they have to go learn Kubernetes and Terraform and Ansible and everything else again. So instead, what we want to do is connect these patterns, this Java implementation, for example, with a definition of, well, how does build work? And we can say, okay, well, build might do a Docker container and then push that into Artifactory. And we might have a deploy action that triggers, Terraform and Helm. And we might define restart by talking to, Kubernetes and doing a restart, etc. Right? So we can define these actions, but in a way that the user doesn't have to care. They can then just come and say, because I picked Java, I have access to run the build command or the deploy command, and I don't need to know how it works. So the goal starts to become, when we think about this life cycle, there's the things that our operations teams will care about, and there's a set of things that our developers will care about. And so how do we solve for these? By allowing the ops teams to define the patterns, to define the workflows, and allow the developers to easily consume them and deploy them, right? And this way we can solve for that entire life cycle by having the central team own the governance of this, but letting 10, 100, 1,000 application teams deploy and manage their applications, right? So together, this starts to form our overall vision for how we think about infrastructure lifecycle management. It's really about all of these activities through the whole life of an app, not just the day 0 deployment of it, and making that integrated across multiple products to solve for developers, security, and operations. So then if we think about the security challenge, sort of a different set of workflows we have to worry about, right? If we think about the core of security, at the end of the day, it's about a set of outcomes. So we might define a goal that says 99% of my secrets are vaulted or protected, and that I rotated everything in the last 180 days, right? This might be a very straightforward security goal. We obviously want our secrets to be encrypted so that an attacker doesn't find it, that we don't have, sloppy management and it's in GitHub or it's in plain text. And we want it rotated so that if a credential is accidentally leaked, it's not valid for years and years at a time, right? And an attacker finds it and uses it. Same from a compliance standpoint. Most compliance requirements require that you're rotating keys and certificates on a regular basis. So we start with a simple goal, and then you work backward. And you start to say, okay, well, what's the first problem here? The first problem is to know if 99% of my secrets are vaulted, I need to know where 100% of my secrets are. So my first problem is an inventory problem. I need to actually know where is 100% of my secrets to start with. So this is where we've bought a product called Radar. And the goal of Radar is you can plug it into all of your different systems. So Git, Jira, Confluence, Teams, and Slack, and so on. And the goal of Radar is it's going to go scan all of these systems to look for secrets. And what we find over and over again is there's secrets in places you never thought there should be, right? Somebody had an issue with the database, so they opened a Jira ticket and they put the database credential inside that. Someone wanted to create a run book for how you restart something in Kubernetes, so they made a page in Confluence and they put the Kubernetes API keys in that run book, right? So these secrets end up everywhere. So you run Radar, and it's going to come back and say, okay, great, I found 50,000 secrets in the environment. So now we want to go take those secrets and put them somewhere. So the next step is really to vault them centrally, right? So this is where someone will use something like HashiCorp Vault and bring those secrets in. Typically, these secrets are static, meaning we're just taking a static value that was in GitHub and we're putting it in Vault, but it's not changing in an automated way, right? And so this tends to be a long-lived secret that's shared by every application that's reading that secret out of Vault, right? So think about a database username and password. You might put it in Vault, but every app that's asking for it gets the same database password back. So these two layers start to solve this part of the goal. Now we can say, I can detect all my secrets. I can centrally manage them, so it's encrypted. I have audit control. I have access control around it. But it doesn't solve the other part of my equation, which is, are they all rotated? And so when you start to think about a large infrastructure where you have 10,000, 50,000 secrets, the idea of rotating everything manually is very impractical. It's very hard to do when you have thousands and thousands of secrets, right? So you have to think about, how do I do it in a way that's automated? So the first step becomes what we call auto-rotation. So you might take a database password and give it to Vault and say, change the password every 30 days automatically. So Vault will log into the database and go update that username and password every 30 days without the user having to do anything. So this starts to move you to a medium-lived secret that's still shared across every application. Every app that asks for the database password is going to get the same one, but they know that that password's changing every 30 days, right? Ultimately, where we want to get to is what we call a dynamic secret. This is a short-lived secret that's unique to each client. Every time you ask for the database password, Vault will go create it for you on demand. It will go talk to the database, make a new username and password, and it'll be very short-lived, maybe only hours or 1 day at a time. And at the end of that time, Vault's going to go back to the database and destroy the username and password. So as we kind of move down this hierarchy, the passwords get shorter and shorter time to live, and that's how we solve this part of the problem, right? We can be sure as we get to things like auto-rotated and dynamic secrets that everything is rotated within 180 days, because the auto-rotation maybe happens every 30 days, the dynamic credential is only valid for 24 hours, so none of these credentials live 180 days, right? They're being changed much more rapidly. So this is how we start to solve the combined goal, right? When we think about bringing these different pieces together. Now, across all of these, when we're talking about Vault, we're really solving the machine-to-machine problem. Meaning, in practice, you might have a web application that wants to talk to a database, so it's using Vault to get those secrets. It's going to talk to Vault. Vault might be dynamically managing the database credentials, and then the web application is using those credentials to connect to the database, right? So this is application to application or machine to machine. But what about our users who also want access, right? I think more often than not, when we look at attacks and compromises, it's actually the users that are the weakest link in the security of a system, right? Because they tend to have too much access, they're on the network, they open an email that they shouldn't, and now you have a highly privileged user who has access to a bunch of different systems. So if we look at the classic access path, a user first tends to connect to a VPN to get on the network. So challenge is this puts the user onto our production network. From there, we typically have a firewall that restricts what the user has access to. So now we have to manage a set of IP rules. And in practice, because the IPs change so much, we don't manage these effectively. So it usually allows any traffic to any other traffic. Then we might have a privileged access management tool to get the certificates or credentials, so then we can access something like Vault. And this introduces another point where we have to manage static credentials. So we looked at this and we said, well, this is obviously a problem in cloud. Our infrastructure is very dynamic. We don't want users to be on the network, because what ends up happening is if they're on the network and they're compromised, you can move broadly throughout to systems you shouldn't have access to. Maintaining firewall rules is too complicated in a cloud world because the infrastructure is very dynamic. And I don't want another location to manage static credentials. So this is why we created our Boundary product. So Boundary runs at the edge of the network, much like a VPN does. So the user will connect to Boundary, but unlike a VPN where you might have a username and password and a certificate, Boundary uses a single sign-on from your identity provider. So if you're using an identity provider, you just do a single sign-on. You have no separate credential. You have no VPN certificate. You have no key, right? Then we define an identity-based rule. So we might say our database administrator, they have access to the database. So now as this user, when they log in, the only thing that they see they have access to is the database, even though there might be thousands of other resources on the network. So when this user says, I want to connect to the database, Boundary will act as a proxy to directly connect them to that resource. So very importantly, unlike a VPN, the user is never on the network. Now, because their access is limited to only what their identity lets them do, we actually don't need the firewall either, because Boundary is much more limited and secure versus what a firewall is going to do, which is only look at your IP. It doesn't know what your identity is. Then to solve the PAM problem, Boundary integrates directly with Vault. So in the case of a database, rather than have a static, long-lived username, Boundary will connect directly to Vault and use a dynamic credential. So Vault will create a unique credential for the database. The user can connect, do whatever activity they need, and the moment they disconnect from the database, we talk to Vault and we delete that username and password. So the user and password connecting to the database, or maybe they're SSHing to a machine, will be perfectly unique to that one session and destroyed the moment the session is over. So there's no risk that it gets leaked and another user or an attacker is able to use that credential to get to the database or SSH into the machine. And so the goal is basically to keep the users off the network, reduce the complexity of the number of rules that we're managing, and really move to a least privilege model or a zero trust model of how we think about security. So then Boundary works alongside of Vault and Radar to really solve this entire life cycle, right? So when we think about the life cycle end to end, it's really about, again, starting with saying we do the discovery of the credentials with something like Radar. We manage them centrally in a system like Vault and increasingly automate the life cycle of them, moving to dynamic secrets. And then we enable users to access those same secrets and systems through something like Boundary. And in this way, we have an integrated workflow between these, right? Now, you might look at it and say, well, what does security lifecycle have to do with infrastructure lifecycle? Why do we care about both of these problems? The reason these things are dependent on one another is because you can't do secure infrastructure lifecycle without thinking about security, and you can't do the security in a safe way without automation. What do I mean by that? Let's take a classic example. As the user, you might want to deliver an application into production. So we think about saying, okay, user's going to commit some code, to their version control system. And now we want to have a CI/CD process, which is going to securely deliver that application to production. So we might say, okay, great, as part of our pipeline, we have a tool like Terraform. So we might create a pipeline and say, great, I'm going to pull from that. I'm going to have something like Terraform. So it's going to be infrastructure as code. And we're going to declare to say, okay, how do I deploy my application into my cloud environment? So I might run a tool like Terraform, and great, it's going to provision, who knows, let's say a Kubernetes cluster, or it might be a VM. And we're going to place the application on top. Now in practice, this application needs all sorts of things. It needs a database credential. It needs a TLS certificate. It needs encryption keys. So now the question is, okay, well, how did this application get these credentials? What we often end up saying is, great, well, one easy answer is, we'll just hard code those credentials into the version control pipeline or into our CI/CD pipeline. And now the problem is I have all sorts of encryption keys or certs that are exposed in Git, or they're exposed in Jenkins, right? So you look at ITIL and say, okay, well, that's the wrong thing to do. Instead, our pipeline should include a system like Vault to say, great, the application's going to go query it from Vault. And so now these certificates, database keys, encryption keys, none of them live inside the pipeline anymore. So to do infrastructure lifecycle correctly, where we're saying, okay, we're going to automate the delivery of the app and do it in a secure way where I'm not exposing the keys, I actually had to think about security lifecycle management. And if you think about it in reverse and say, okay, what if I start with Vault, but I don't have a CI/CD pipeline? Well, now this application that's deployed on a VM, when it needs to authenticate to Vault, somehow it has to authenticate and log in. How do we do that? If this VM is manually provisioned and deployed by a user, or it's manually deployed to Kubernetes, then it means the same user has highly privileged access to Vault. So I don't want that. Instead, I only want the CI/CD pipeline to be the tool that can talk to Vault, and not the end user. So the two of these go hand in hand, right? To really do security well, I don't want users to have access to systems like Vault, because that creates a security issue for me. And to have automated delivery pipelines with tools like Terraform, I don't want my applications to hard code secrets and certificates. I want to dynamically fetch them from systems like Vault. So you might think that these are very separate problems, but really there's a very tight relationship in terms of to do one well requires the other one. And we often see this challenge in cloud, where people will start with one and do automated provisioning, but because their security isn't automated, they have credentials hard-coded in their estate, or they have to file a ticket and manually generate certificates, and so they have a bunch of insecure process of how it's delivered. Same thing if you focus on the security, but you don't have automation. We often see that you have a ticketing workflow where someone's filing a ticket to then go talk to Vault, and now you have your certificates all over the place as well, right? So these things are highly, highly connected, and in the end, we think about managing them and automating them sort of end to end, right? So the other piece when we talk about the infrastructure cloud is then what are the different flavors of how HashiCorp delivers this? You know, we started many years ago, and we started with open source as the core of how we delivered. And this allowed everybody to download and execute it wherever you want. And you had to kind of run it yourself. Over time, we then focused on delivering enterprise versions, which really took the open source and were focused on the day 1, day 2, and beyond in terms of the workflow, but you still had to run it yourself. And I think increasingly what we've heard from customers is, well, we don't want to run this stuff. Can you just run it for me? So the cloud versions bring all the enterprise features, but instead of having to run it, it's delivered as a fully managed SaaS experience, right? So HashiCorp delivers it, runs it, operates it, patches it, upgrades it, whole 9 yards. And so what you'll see is increasingly as we focus on the cloud side, it's how do we enable an integrated experience across the products, right? Which is very hard for us to do in either the enterprise or the open source because we don't know which versions you're running, we don't know how they're configured, we don't know which versions they are. Versus in cloud, because we can control all those things, we can drive a tight integration across Packer to Terraform, Terraform to Waypoint, so on, right? And that's really our focus when we zoom out and think about cloud done right. It's to deliver those set of patterns and those integrated workflows across the broader portfolio. Because if we zoom out, this is a lot of complexity. So how do we make this easier for our end users so we can automate this and deliver it in an opinionated way? I hope that was helpful. We have a lot of other great content planned for the rest of today. So we're going to go into more detail on the infrastructure lifecycle, and you're going to hear from a HashiCorp solutions engineer showcasing the products and how they really work together, taking it from the whiteboard into reality. And then you're going to hear from some customers about how they're using products like Terraform, like Vault at scale in their environments to solve some of their cloud challenges. So thank you so much for all of you making the time to join us for this strategy day. Looking forward to talking with all of you. Take care.